Physical time travel is a difficult business. Visual time travel, however, is easy. In fact, you do it every time you look up in the sky. Light may be the fastest known thing, but the universe is also incomprehensibly huge. So it takes great lengths of time for even light to reach us. This means that when we peer into the night sky, we're only ever seeing the stars as they were in the past, and usually, the distant past. The sun, for example, is far closer to us than any other star in the universe, but it still takes approximately 8 minutes for its light to reach us. What that means is that we only ever see the sun as it was 8 minutes ago. Similarly, the nearest galaxy to us is the Canis Major Dwarf Galaxy, which is 25,000 light-years away. But that means that whenever we look at it, what we're actually seeing is a snapshot of that galaxy as it was 25,000 years ago. The truth is, then, that the further out into space we gaze, the further back in time we're effectively seeing. And all the stars, planets, and galaxies that exist out there already have their fates sealed. It's just that those fates are completely unknown to us right now, and they'll stay that way until their light reaches us. With that in mind, judging the plane distance of stars is also a challenging task, and one that scientists have been working on for thousands of years. The ancient Greek astronomer Hipparchus, for example, first tried to measure just the moon's distance from Earth by employing a technique called parallax, a system which works on the mathematical principles of trigonometry. And to some degree, parallax can still be used to calculate the distance to objects that are further afield too, including stars. Brightness is also a factor in any one thing's visibility, however. So the most distant objects measured tend to also be the most massive galaxies, because they're the brightest. These are huge structures, though, made up of countless stars in themselves, so a single star is a different prospect. A single star is clearly much smaller and much less bright. Nevertheless, until a recent breakthrough, the farthest ever star spotted had been the Icarus star, around 14 billion light-years from Earth. Its light had traveled 9.3 billion light-years to reach us, accounting for expansion. But now scientists have spotted another that blows that previous record out of the sky. In March 2022, details of a study led by the astrophysicist Brian Welch were published in the journal Nature. Welch and his team had analyzed images from the Hubble telescope, noticing a large red arc in the shots of a galactic cluster, which was the result of that cluster exerting massive gravitational pull on the surrounding fabric of space-time and bending light itself. It created what's known as a gravitational lens. Lensing occurs when space-time is bent in such a way that it magnifies the light behind it, similar to how a magnifying glass works or the lens of a telescope functions. This process can be extremely fortunate for astronomers, though, because it allows them to effectively see further than would ordinarily be possible. Even objects that are now farther away than the age of the universe itself, for example, thanks to universal expansion, might be picked up thanks to lensing. In this case, the chance gravitational lensing effect has allowed astronomers to spot a particular star, now nicknamed Arundel, at an incredible distance of 28 billion light-years away. That's around double the distance to Icarus, the record holder until now. If the calculations are correct, then Arundel's light has traveled 12.9 billion years to reach us, almost 4 billion more than Icarus, meaning it will have existed when the universe was truly in its infancy, and perhaps only a few hundred million years after the Big Bang itself. Again then, while the light of Arundel has only just arrived for us, what we're really seeing is that star's distant past, a snapshot of the early universe, meaning that Arundel itself is currently in a wholly different state. What we see now is almost like a ghost of the current star, especially as the chances are that it may have long since died out. While stars like our Sun can last up to 10 billion years, more massive stars tend to burn out quicker. And it's thought that Arundel could be around 50 to 100 times more massive, meaning it should have had a much shorter life. In fact, it's already been suggested that it may have only lived for another few million years before going supernova. So although we've only just discovered it, Arundel is almost certainly long gone and no more. In cases like this, astronomers can be thought of as something like archaeologists of the skies, uncovering the artifacts and remainders of long-dead stars and galaxies. However, due to the limited number of Hubble photographs, further details about Arundel are limited too. It's thought that it likely has or had a surface temperature of around 36,000 degrees Fahrenheit, while researchers did confirm that the name given to it was inspired by a J.R.R. Tolkien character. Beyond that, predictions for Arundel are increasingly difficult to make, although there's one emerging and exciting theory that it may be a population 3 star, which is a theoretical star type that contains only lighter elements and is thought to have existed only at the beginning of the universe. A population 3 star has never been seen before, so if confirmed, Arundel could also come to be known as the first example of one, as well as being the most distant star ever observed. The timing of the discovery is also fantastic for further study. The recently launched James Webb Space Telescope is set to be tasked with taking more pictures of Arundel and compiling more data as part of a long list of missions for the new device. Researchers also aren't particularly worried about that fortuitous gravitational lensing effect going away. Though it will eventually disappear, it's not expected to in the near future. Ultimately, the study of this star has the potential to answer some very important questions in astronomy. Because Arundel is so old, potentially forming less than 1 billion years after the beginning of time, and when heavier elements weren't as abundant, it offers astronomers a unique opportunity to peek into the conditions of the very early cosmos. However, scientists are also hopeful that Arundel's record won't hold for long. The James Webb Space Telescope, with its superior vision and sensitivity, is capable of seeing things that other telescopes can't, and could therefore soon find another lensed star even older than this one. It's perhaps strange to imagine that the most distant star we can see in the sky right now has also likely been dead for billions of years. But really, the same goes for anything in space. Were we to one day spot evidence of a civilization far, far away, the chances are that we'd only be seeing an after-image of it as well. Similarly, were aliens in another galaxy to look in our direction, and assuming they haven't devised a way to skip the limits of light speed, then they could well see as far back as when the dinosaurs roamed the land, or they might even see a barren, newly formed planet as Earth was a few billion years ago. But in either case, they would have no idea that we were here today. What do you think might have happened on Arundel in the time since it emitted the light that we're only now just making sense of? There are billions of years to consider, taking us back from today to almost the beginning of everything. It's little wonder that Arundel's discovery has caused so much excitement, because it's not every day that you get to travel so far back into the past. And that's how scientists just discovered the most distant star ever.